world-class Rays forged wheels. The culmination of Rays Engineering's advanced technology and expertise. Taking advantage of the strength and lightness obtainable through forging. Original manufacturing methods and select materials leads to the pinnacle of forged wheels. Combining materials and technology to create the ultimate in aluminum wheels. Let's see how these forged wheels are made. The manufacture of forged wheels begins with the selection of the best possible material. Based on the aluminum 6061 alloy, these billets are comprised of our original premium blend aluminum alloy, developed with an emphasis on strength. Prior to forging, the billets are first heated to over 500 degrees Celsius to enable the material to be shaped into various innovative designs. Using the heated billet material, we finally move on to the modeling forging process. TE37 Saga wheels are shaped using mold form forging dies in 3 stages. In the first forging, the billet material is made into a pancake shape with a diameter close to that of the finished wheel. The forging press applies several thousand tons of pressure, approximately 5 tons per square centimeter. From the second forging, a step-by-step mold forging from the pancake shape is performed. To achieve lightweight spokes, the cross-sectional shape is formed by forging from the backside. As you can see from the 3D model, the center of the spokes is hollowed out. Next is the third and final stage of shape forging. Together with the wheel design's overall shape, the hollowed-out portions formed in the second forging are transformed into U-shaped cross-sections, characteristic of thin-walled forging. Lightweight is the aim of this final stage, and a seamless grain flow is achieved through this unique die forging method to obtain the desired design, strength, and rigidity. This die forging method employs Rays Engineering's proprietary shuttle-type die forging system. Rays Engineering developed a shuttle forging press machine that slides the forging die sets from 3 directions to perform the first, second, and third forgings. This forging press can apply a forging pressure of up to 10,000 tons. The key to maximizing forging performance is the forging die's design. In the 3-stage forging used to transform the billet material into a wheel shape, the wheel's design side and reverse side are integrally shaped by 3-dimensional shaping using the die forging method to form high-strength, high-rigidity, U-shaped cross-sections for the spokes. Rays Engineering's designers combine expertise, creativity, and a thorough understanding of the materials and manufacturing equipment with leading-edge forging technology. This RM forging machine is also our original technology. In addition to forming the final detailed shape, it uses proprietary dies to simultaneously form the outer rim and the flaring of the inner rim. Similar to the mold form forging process, the material is heated, and the heated wheel is rotated as the roller flares the inner rim. When metal is heated and compressed, such as in forging, fiber-like lines called grain flow appear. No machining is used to form raise wheels, only the mold form forging made possible with our unique die forging method, guided by the experience and knowledge of our design engineers. As a result, the grain flow lines fan out from the center of the wheel in a distinctive pattern, like the fibers of bamboo. This spinning process forms the inner rim's final shape. Inner rim molding from 5J to 13J is possible with a flexible mold. By taking advantage of the elongated characteristic of the aluminum alloy that is uniquely compounded. Following forging and rim forming, the aluminum alloy is heat treated in order to maximize its unique properties. The heat treatment process consists of quenching and tempering. This heat treatment process is precision controlled to maximize the aluminum alloy's three key mechanical properties of tensile strength, proof stress, and elongation. As a result, even with a lightweight, thin-walled rim, good steering stability and suspension stiffness are maintained during cornering. The material of the forged wheel, which has undergone heat treatment, undergoes mounting processing in advance of the tire inflation and vehicle attachment processes. In two processes, both the outside and inside of the wheel are machined to achieve a precise balance within 1/1000th of a millimeter, an essential factor. PCD drilling is another process that requires high precision, since the balance of the wheel's mounting points on the vehicle is a critical factor. The air valve hole is also drilled parallel to the well angle of the wheel. Burrs remaining from machining on the spoke edges can reduce corrosion resistance after painting. To prevent this, Raise Engineering developed a method using a special tool that rounds the spoke edges on the rear side of the wheel during the machining process. This edge trimming ensures better adhesion of the coating film that's formed in the painting process, improving corrosion resistance for the wheels, which are subjected to corrosive conditions due to their proximity to the road surface. This edge trimming method is a patented Raise Engineering technology. Knurling is a process that improves wheel performance on race cars and other high horsepower vehicles. It helps prevent slipping between the tire and the wheel that might occur due to repeated sudden acceleration and deceleration. Eddy current testing is used to inspect for hairline cracks invisible to the naked eye. In particular, the camber force that is repeatedly exerted on the inner rim edges during driving can cause cracks to appear in the rim if there are any internal defects, leading to a loss of driving performance that could potentially pose a serious risk. Considering possible worst-case scenarios, Each wheel is methodically inspected for defects. Wheel strength, rigidity, and balance are essential to ensure safe, comfortable driving. All three factors are numerically verified right from the design stage. Here as well, our designers' knowledge and experience are a solid foundation for design plans to create ideal wheels that are strong, lightweight, and beautiful. Proven designs are the basis for Rays Engineering's wheel manufacturing. Radial load fatigue tests evaluate disc fatigue durability. The Japanese government's JWL standard requires 100,000 rotations, but Rays Engineering has set its own plus R standard of 200,000 rotations. This ensures sufficient performance to withstand the lateral G-force during cornering in severe driving conditions. Simulations at the design stage enable predictive design to guarantee the required lower limit. Now let's look at the appearance-related processes. In the final stage of manufacture, the wheel surfaces are carefully polished by hand to remove the lubricant applied during mold form forging, as well as galling marks from hot forging, so as to ensure a beautiful finish for subsequent decorative painting. This work relies on the skill of Rays Engineering's dedicated staff. Shot blasting has two purposes. First is to increase strength. While the forging, heat treatment, and machining processes already ensure ample strength, shot blasting is performed using stainless steel beads to make the wheels even stronger. Second is to level the forged surfaces. Painting the forged surfaces as is would not achieve the desired beautiful appearance. Wheel surfaces are degreased prior to the powder coating undercoat. There are three processes: alkaline etching, acid pickling, and chemical conversion coating. A chemical conversion coating is formed on all wheel surfaces to ensure good adhesion of the paint and enhance corrosion resistance. The rotary degreasing system seen here uses a dipping method patented by Rays Engineering that ensures a uniform chemical conversion coating. The powder coating undercoat is then applied to the degreased wheel. The advantage of this powder coating is that its thickness enhances anti-corrosion performance. It also serves to level any unevenness of the forged surfaces. After the undercoating, a variety of solvent coatings can be applied, depending on the desired specifications for each wheel. According to the design specifications, diamond cutting is performed after painting for a lustrous shine. Our original aluminum alloy material is characterized by its lustrous shine. Designs that bring out that luster are achieved using diamond chips. This is essential for deep rim specification wheels that have a deep outer rim. To maintain the anti-corrosion performance of the diamond-cut surfaces, diamond-cut wheels are treated using the rotary degreasing system seen earlier. This entails the same three processes: alkaline etching, acid pickling, and chemical conversion coating. Again, the Rays Engineering patented dipping method ensures a uniform chemical conversion coating. A clear coat needs to be applied to the diamond-cut wheels as soon as possible after degreasing. So, after air blow drying, the wheels are sent to the painting booth area. Rays Engineering's factory automation line system prioritizes anti-corrosion performance. After degreasing, the wheels are transferred by robot or PLC-controlled lines to the solvent coating booth area. The clear coat is applied in 2 stages. First primer, then the clear coat. A variety of transparent and colored clear coats are available to meet specific needs. The most prominent feature of AMT, Rays Advanced Machining Technology, is the ability to engrave markings on wheels after a coating has been applied. With AMT, the grooves cut by the machining tool are left as is. This enables letters and other delicate markings to be engraved as continuous lines. No matter how difficult the engraving, our proprietary machining center achieves a production speed and quality rivaling mass-produced products. With RE-DOT, Rays Engineering Drawing Object Technology, a bubble jet spray system is used to apply a second coating of solvent onto the wheel design face as an accent color after the first color has been applied. Employing application devices with coating supply heads that make possible the application of colors and decorative designs, Rays AMT and RE-DOT are leading-edge technologies that achieve mechanical designs never before possible to reach new heights in wheel design. As you've seen, most forged wheel manufacturing processes are performed by machines. But the final inspection requires human eyes and hands. Inspectors apply all of their considerable knowledge and expertise. As the final inspection is the closest step to the end user, it can only be performed by expert craftsmen with years of experience. Before finished wheels are released onto the market, they undergo a battery of durability tests. Here, the rim disc's strength and its ability to hold the tire's air after a hard impact are assessed. In the JWL standard impact test, a weight of 500 to 600 kilograms is dropped from a height of 230 millimeters to assess impact resistance. But that's not enough for Rays Engineering. The +R standard from a height of 305 millimeters is used to assess the impact force exerted on the wheel, such as when driving over a curbstone or a speed bump. Die forging gives Rays wheels the resilience to withstand such impacts, and is verified in simulations from the design stage. Wheel durability is assessed using drum endurance tests. The JWL standard requires 500,000 rotations, but Rays Engineering has set its own +R standard of 1 million rotations to ensure that wheels can withstand vertical loads exerted by continuous driving in severe conditions. Rays wheels can meet this high standard because the forged material has a high fatigue strength and the wheel's composition is uniform, so the strength is also uniform. Certification stickers are applied to wheels that satisfy the +R standard. These stickers are proof of having passed the most rigorous testing. Ray's Engineering's original forged wheels. Thanks to unique wheel designs that meet global demand and the advanced proprietary technologies used to manufacture them, Ray's Engineering continues to be a leader in the field. Taking forged wheels to impressive new heights, Ray's Engineering.